Okay, so welcome to Faraday's channel, episode 2 of the basic mechanics. And then today we are going to solve another 2D problem. This is more or less like a pole, and then we have string attaching it for support. Okay, and then the question: the cable stays AB. The cable stays AB. That is what we have the AB, and what AD helps support AC. So this is what the pole AC, and then AB, and that of the AD is what in support. Okay. Knowing the tension is 120 Newton in AB. So the tension in what? This particular force is what? 120 what? Newton. And 40 Newton in what? AD. And that of AD is what? 40 Newton. Right? We want to digest this small and go. Okay. Determine the magnitude and direction of the resultant of the forces exerted by the states at what? A. Now it means that what? The support is actually taking place at what? A. And then the pole is what? AC. Okay. Now because it's a tensional force always acts in opposite direction to the what? To the where the force is being exerted. So whereas we have the states at this side, but then because the tensional force is what? It is going to what? Move in what? This particular direction. And similarly, this is also going to move in this particular direction. So if we are to draw a simple diagram for it, then we can have something like the main plane, our line. And then we have our main point where the force is acting at A. And then let's say the support at this point in the y-axis, okay. And then the angle it is making with this is what? Let's say we have this particular angle. And then there's another force here, right? And then we can call that particular force 120 watt Newton. This is also what? 40 Newton watt force. So I can choose to call this one what? F1. And this force will be called what? F2, right? And then we don't know the angle it is making in the what? With the y plane. Okay. Yes. So we don't know the angle, the force, this particular force, which is the tension, is making with the what? With the y-axis. And similarly, we don't know the force this one is also making. So, but then we have been given the distances, right? So we can use the distances to solve it, or we can find the individual angles from the distance. And then this is so easy for us. So let's do it. So let's look at the angle this one is making with this. We can have something like this. This was the plane. And then we have this, right? So we can have something like this here. And then we know the distance here is what? 6 centimeters, right? And then the y plane, this one is the same as this side, right? And which is what? 10 centimeters. Can you help me with it? So if you want the angle here, what do we do? Theta. If you want the theta, we can use tan, which is what? Opposite over what? The adjacent. So tan what? Theta is equal to the opposite over the what? The adjacent, which is what? 10. So it means that our theta will now be equal to what? Tan inverse of what? 6 on what? 10. Which will give us the what? The angle this one is making with it. That was what? What is the angle this one is making with it? So tan inverse of 6. That will give us 31 point what? 31. Okay. That's 31 degrees Celsius. And then similarly, we can also find the angle this one is also making with what? With this. And then that one, we have this one to be 10. Which is equal to this. And then we have this one. So the same thing. So we can, that one, so theta, other theta will also be equal to tan inverse of what? 8, right? All on what? The adjacent, which is what? 10. What will be the angle? So we had 38.7 degrees Celsius. The next thing we do is to move on to find the what? To resolve it what? Individually into the x and y plane. So we have this force. Because the force is acting inclinedly, it means that we are going to look at the resolve this particular force or tension is making with the what? The x plane. Similarly, we are going to look at the result it's making with what? The y plane. And I said it clearly that anytime it is moving down, you assume it is negative. And if it is moving up, it's what? Positive. And then similarly, if it is moving in the right direction, it's positive. If it is moving in the left direction, it's what? Negative. Okay. So we are now going to resolve the forces into x and y planes since we have now gotten the angles, right? And then I said that anytime it is moving into the right direction, it is positive. If it is moving into the left direction, it's what? Negative. So if it is moving into this one, it's positive, this direction. If it's moving into the y direction, it's what? Negative. This is also negative, and this what? Positive. If it's moving upward. Okay. So we have F1. The F1, we are looking at the resultant of F1. Resultant of what? F1, right? So F1 falling in the X plane and falling in the Y plane. So F1 in the what? In the X plane. So that will give us what? 40 is going, and then I said that anytime we know the angle to where we are going, it is what? It is what? It is sine. Anytime we know the angle to where we are going, it is cos. So resolving into, if it is this plane, we are resolving into the cos. But we don't know the angle to what? Where we are going, which is the what? The X plane. So we don't know. So that will give us what? Sine. Very good. So sine 31 degrees plus. Now we also want to resolve this one. So we can call this one ix, so that it will be easy for us. Ix in the X plane. Similarly, we want to resolve it into the Y plane. Realize that when we resolve it, the arrow will now move down. And I say if it is down, it is what? It is negative. So this will also give us what? Negative of what? 40 what? Cos what? Cos what? 31 degrees. So it means that the resultant force will give us what? I what? I y. Very good. What will be our resultant force? 20.6 Newton Ix plus what? Minus 34.29 what? Newton what? Iy in the Y plane. So let me resolve the other forces. So let's say the force what? The 120 forces to. The resolution will be what? So here we are going to resolve it to the one y and x. So now realize that in the x plane, we don't know the angle to where we are going. So it is what? Sine. So we have 120 sine what? Sine. Very good. So 38.7. Or you could also say that what? Since this one is forming 90 degrees with this angle, you subtract this one from y. 90 to get the one here. And then in that case, you know the angle to where you're going. So it's going to be what? Cos. Very good. So this one is this. You realize that the arrow is moving in this direction. So after resolving, the force will move this way, which is in the negative direction. So this one becomes what? Negative. Can you see that? Very good. And then resolving into the y plane. That will give us what? Negative, because it's moving down. So 120 what? 120 cos. We know the angle to where we are going. So cos what? 38.17. So f of what? 120 will give us what? Negative 75 point what? 03 Newton Ix minus what? What did you get again? 93 point what? 65 what? Newton. I what? I of y. So after you are done, you just need to what? Add all the what? X plane and that of the y plane. And I said almost all the time, your main aim in 2D is to be able to resolve all the forces into what? X and y. So let's find our resultant force. So our final resultant force in the X plane will be what? Addition of these two. And that will give us what? So add it for me. So you add these two together, this and this. So minus what? 0.43 what? Newton. So in the X plane, right? And then adding these two together to minus point what? 0.94 what? I what? Y. So this is the resolution of the forces. So if you go into the plane, these are just telling you the direction. These ones are telling the direction. What you do is that we have the force here. They are all moving in the negative direction, right? So in the y plane, we could say that what? The force is moving down. Can we say that? Because it's negative. It's negative here. And in the x plane, you can say it's moving what? This way. Can you say that? So we have what? In the x plane, we can see the force is what? 54.43 Newton. And then in the y plane, we can say it's what? 128 point what? 94 what? Newton. And this one is the what? The resultant force. So assuming we are told to find the magnitude. So the question says determine the magnitude. And we know that the magnitude is the same as what? Finding the Pythagoras form of what? The result you have. So here we know that anytime we want to find the magnitude, f of r will be equal to the square of this, right? Root of, very good. So we have root of what? What was the value? 50, right? So we can ignore the negative. 54 point what? 43 all squared plus what? 128.9 what? Squared. 94. Okay. So that will give us FR will give us what? 139 point what? 96 Newton. So that is the magnitude. So assuming the question says that what? And determine the direction of the resultant force. So it simply means that you find the force the FR is making with the what? The x-axis. And that's so easy. Because if you want to find this angle, you can use this and this. So we can see that tan theta will be equal to what? The opposite, right? That will be 128 point what? 94. So that will be, let me even do it straight. Or divided by 54, right? 0.43 what? Newton. And we can find tan inverse to get the angle. So the theta will give us what? What will be that? What did you get? 60.07 what? 0.8 degrees Celsius. So this is the angle it is making with the what? The x-axis. So thank you very much, and that is all for the 2D. Our next video we are going to move on to 3D, and you realize that 3D is more easy compared to the 2D, if only you understand the movement of it.